are starting unit number 4, and kicks off with CO25. This is I should actually go to the start. Usually when we start a new unit, especially a new binder, look at the table of contents here. It's kind of a shorty. We're not going to get it done before Christmas break, so we'll probably stop after CO27. But we're going to talk about some more graphing things, something called direct variation today. Then we're going to get into a different form of a linear equation. So far you've learned about slope-intercept form and standard form. There's a third one called point-slope form. So we learn how to write it. Then we learn how to graph it. So that's 26 and 27. Then we talk about special types of lines, parallel lines, perpendicular lines, or neither. Okay. So 2 POs, both of them come at the very end. PO29 correlates very well with PO24, where you're writing the equation of the line. Where you had to solve for the y-intercept, find the slope, things like that. But kind of a shorter unit. Then in unit 5, we get into inequalities and absolute value functions, a different type of equations. And then unit 6, we talk about scatter plots. And things really get algebra heavy starting in unit 6 and going beyond with this whole system of equations deal. Okay, and so we are really accelerating after this graphing inequalities unit. We really hit the crux of algebra. We also start to see some algebra 2 concepts sneak in as well. So things really do pick up in try 2. Yes.
So how many units will we have this year?
Hopefully 10, probably 9. Yeah, hopefully 10, probably 9. So the further we get, the longer the objectives take, because the work gets to be pretty involved and you need more examples. So it won't be uncommon, especially in try 3, for an objective to take 3 days to do, right? And so we, if it all goes well, we'll cover 64 objectives during the course of the year. We're already on 25, so we only have about 40 of them to go. But we do slow down a little bit because it's all new stuff and it takes a long time to do.
I have a quick question. How often is Mr. Lake come?
He's usually here every day after school that I am, Mondays and Thursdays. This week I'm not after school at all because of meetings and things like that. Mr. Olink is a grandparent of St. Vincent students who enjoys math, and he likes to come in and help kids with practice work and math packets and things like that. It really helps to have him here because if I'm, up at my desk and you need help out here, my line's long, he can come over and give you some assistance. But anyway, starting the new unit, CO25, we're talking about direct variation. Like we discussed in CO21, a relation with slope is a linear function. These two things are directly related. Okay, if something has slope, it is linear. If it's linear, it has slope. And we're going to talk about another special type of linear function called direct variation. Okay, and essentially, direct variation is how do I want to word this? The elementary way is that when it takes one step to get from X to Y. Another way to say that would be X and Y are proportional. Okay? It takes one step to get from X to Y. X and Y are proportional. I'll give you an example of what I mean by that in just a little bit. Okay? So when it takes one step to get from X to Y, and X and Y are proportional. There are 2 ways to define direct variation. For example, if we have a function table where X is 7, Y is 21, X is 5, Y is 15, X is -2, Y is -6. Tell me how it takes one step to get from X to Y. How does that example fit that definition? Kaylin? Right. All you have to do to get from X to Y, 7 to 21, 5 to 15, -2 to -6, is multiply by 3. One step. Okay? How are they proportional? How are they proportional? How does it fit the second part of that, Nick?
Because they're all multiplied by 3, so they're like so they're all the same.
Yeah, if you were to take 21 divided by 7, or 15 divided by 5, or -6 divided by -2, you get that 3, right? They're proportional because they all create equivalent fractions. Because remember, a proportion is simply a pair of equivalent fractions, okay? So that's what we mean by it takes one step to get from x to y, and they are proportional. An example of something that would not be direct variations, I'll do in red, because red is bad. No. This one might be if x is 1, y is 3. If x is 5, y is 11. If x is 12, y is 25. Tell me here, how do I get from x to y? Colin? I would multiply by 2 and then add 1, right? It's a second step, okay? Versus just one step. Also, if I were to take 3 divided by 1, 11 divided by 5, 25 divided by 12, are those equivalent fractions? No, so they're not proportional. Okay? So, example, direct variation, example, not direct variation. To determine direct variation, it's actually quite simple. It has to do with the y-intercept. What do you think the y-intercept of a line would need to be so that there's only one step to get from x to y and they're proportional? I heard someone say it.
Yeah, I said it.
What'd you say?
0.
0.
Someone said it.
Okay.
Really?
0.
I said it.
Determining direct variation. If the y-intercept of a linear function is 0, then it has, or it is, direct variation. Okay? If the y-intercept of a linear, I forgot the word function.
Oh,
Is this a new thing here now? Is this going to be?
you can say he's
Are-
breaking you.
Are we frenemies now? Is that what's happening here?
What's that word?
Explain yourself.
If the y-intercept of a linear function is 0, then it has direct variation. And we can see that with these function tables also. Paisley, just give me a second. This first equation, someone said y equals 3x. If you were to graph that, where's the y-intercept? 0. Okay. This bottom one, which is not direct variation, someone said the equation is y equals 2x plus 1. What's the y-intercept? Positive 1. Right? It's not direct variation. So it's relatively easy to tell if direct variation exists. You're looking at what's the y-intercept. If it's 0, yes, direct variation, proportional. If it's anything else, it's not. Yes.
You said then it has direct variation.
Pick one. Choose your favorite. Whatever you want. Is, has, whatever. Okay. Thank you for pointing out my flaws. All right. Michigan pencil section says write the relation in y equals mx plus b, which is slope-intercept form. To determine if the relation is direct variation. If it is, find the constant of variation. We'll come back to that constant of variation very shortly. You do need to write the equation in slope-intercept form, even though it's very easy to see on this corner plane what the y-intercept is. Just without writing anything down, does this have direct variation?
Yes.
Yes. Okay. And why? Raise your hand, please. Paul. Because the y-intercept is 0. Okay. We can see it passes through the origin. Therefore, we know it's going to be direct variation. But just because it's fun, what is the equation of the line? Leah. Good. Y equals 1/3 x. And of course, that 1/3 came from the slope, right? Up 1/3 to get from one point to the next. And there's no, if you want to write plus 0, you can, but you don't have to. And so this would be the equation in y equals mx plus b form. And the constant of variation. The constant of variation is a fancy way to say, what do we do to x to get to y? What is that constant change in the equation? Nathan?
Why is it not -0?
It could be, but we don't have to write anything at all. Plus 0, minus 0 really doesn't make a difference. Yeah.
Is it the constant variation? Is it 1/3x?
It is. Just the 1/3 part though. Yep. The constant of variation is a fancy way to say slope. Right? Because slope, we talk about it being that change in y or change in x that's constant, doesn't change, it makes that like staircase thing. The constant change, we'll call it the COV, is 1/3. Okay? Essentially the slope. The next one is in slope-intercept form for you. That's fun. Does it have direct variation?
No.
Raise your hand, please. Poldinsky?
No, because y-intercept is 2.
Yes. It is not direct variation.
Nay.
Nay would be correct. Not direct variation because of that. Because the y-intercept is positive 2.
Can we just say
Okay. You can say no.
NUV.
No dv is fine. Ndv.
DOV.
Put the extra O. It's just, okay. So not direct variation, and if there is no direct variation, guess what there also isn't?
Slope.
Well, there is a slope,
constant of variation?
but it's not the constant of variation. Okay? Constant of variation only exists when you have direct variation, because that change is direct. It's a one-step thing. They're proportional. So if there's not direct variation, this equation does still have slope, but it's not the constant of variation because we do something else after multiplying x by 4. Okay? So a direct variation is a very special type of linear function. It only exists when you have that y-intercept of 0. Nick?
So, for number 2, you only look at b, which is number 2, to see if it's.
All you care about is the y-intercept. That is it. Okay? So let's look at the fourth one. We'll do the table in just a second. That fourth one is not in slope-intercept form, so we have to put it there. This is good practice for what we just did in CO25 in our test, convert from standard to slope-intercept. What are we going to need to do to write this in slope-intercept form? Good practice for potential retaking of CO25 here. Katie?
Use opposite operations to get x on the other side.
Yeah, we're going to move x over, right? By subtracting it, using those opposite operations, like you said, we get 7y equals negative 2x. Put the plus 0, minus 0, whatever you want, nothing at all. Either way, it's the same thing. We started with nothing on the right side. If we subtract 2x from nothing, well, we have the negative 2x. If you want to put the plus 0, do it. If not, don't. It doesn't make a difference. It doesn't change anything. Okay? What's our second step? Paisley.
You divide 2 by 7.
Yep, divide everything by 7 to cancel that coefficient out, get y by itself. Negative 2 divided by 7 doesn't work out evenly. Do we care? We do not.
Yes, we do.
Slope is a fraction. Some of us might care. And then 0 divided by 7 is what?
0.
0. It cancels out anyway. Write the plus 0. Don't put anything. Doesn't make a difference. Is this direct variation?
Yes.
Yes.
Yay.
And why?
Because the y-intercept is 0.
Because the y-intercept is 0. Okay? And what's our constant of variation? Negative 2/7. Right? It's the slope of that direct variation. Okay? Questions on anything we've done so far? The most difficult of these to do is the XY table, just because it's the most involved. How do we write the equation of a line using a function table? Knocked off my cap. How do we write the equation of a line using a function table? This is straight out of PO24 from the last unit. Andrea?
So like for the 3 sides, like if you add like 6 to 9 and then 3 to 12 and then 9 to 21, those are all like multiples of 3. And it's the same because if you add 8 to 12 and 4 to 16, and then 12 to 16 to make it 28. It's the same because it's multiplied.
Okay, so kind of like
It's the slope is 3 over 4.
looking for those equivalent fractions, right? Andrea's going back to what we had over on the side here earlier, where we could say, what was it, 7 and 21, 5 and 15, -2 and -6. We said this is direct variation because they're all proportional, right? Because y divided by x is all the same. 21 divided by 7 is 3. 15 divided by 5 is 3. -6 divided by -2 is still +3. Okay? Direct variation is going to exist if, and this is kind of what makes this XY tables a little bit easier to work with here, if y divided by x is the same. Okay? If y divided by x is the same, it has direct variation because they're all proportional then, right? So all we got to do is we got to take each of these ordered pairs and just kind of test it. 4 divided by 3, our first order pair. Is that the same as 12 divided by 9?
Yes.
Is that the same as 16 divided by 12?
Yes.
Is that the same as 28 divided by 21?
Yes.
Yes. Why are equivalent fractions a power objective in Math 6? Because if you don't understand equivalent fractions, you're going to have trouble understanding this, right? Math builds on itself. That's why these power standards, these power objectives exist throughout the curriculum. But anyway, because these are all the same, yes, direct variation exists. And furthermore, what's our constant variation? Cole?
4 over 3.
4 over 3. Y divided by x. Okay, kind of the base fraction, all of these fractions in simplest form, simplify by 4 over 3. Right? Woo! Questions, comments, concerns, complaints, comments, congratulations, principals. Yes, Finn.
Congratulations on your excellent teaching skills.
Thank you, Finn.
What about the bottom one?
We're both on one.
These very bottom. Yeah, Mr. Schultz.
They're all equations. For the bottom section, you are to put this in silver and step form. Get y by itself.
Wait,
Oh, that's just me telling you something.
So we don't have to do that one?
Well, there's not a question mark. Well, there is, but it's not an answerable question. Eli.
So for the second row, 1 over the table.
Yeah.
Do you have to write out like the slope and intercept form?
I actually like for the function tables. You don't have to because we have that little trick. Yeah. Leah. This is homework. Due tomorrow is the rest of CO25. Let's play the number game. I know you can do it, Eli.
And then for second row, the graph. First one, the line really never hits a direct point.
All we care about though is if it hits the origin, right? Does it pass through the origin? The origin's it does. See, the origin's here, right? Does the line pass through that point?
Touch.
No. So is it direct variation? So we're done. Okay. All right, let's go. That's our math.
Don't forget to like and subscribe.
Bye.